this is part 3 of our logic behind the equilibrium shifts, and we're going to be focusing on these problems, number 37, 38, 39, and 40. So let's go ahead and start looking at number 37 right away. Oh boy, old-fashioned smelling salts. What that does is this stuff here is going to make ammonia. Notice this guy's a solid, and so he doesn't have a thing to do with the equilibrium. But these guys do, because they're all gases. So this is also endothermic, which means that the heat is on the left side. So what I've done is over here I indicated heat on the left and that it is a product, or reactant that is. So we're going to add the little plus in here, and I'm just out of room. Normally we'd write it in line. So heat's on the left because it is endothermic, as I highlighted right here. What would the effect on the position of the equilibrium be if the equilibrium reaction were performed in a lower temperature? Aha! We have got to go back now, and we have to see exactly how to handle that. A lower temperature, huh? So, right here, we're going to have lower temp. Now, that's our stress. What is LeChat going to want to do? He's going to want to raise the temperature. And he is going to have to raise the temperature by shifting to the same side as where the temperature is. Because raise or increase or add, see, this could also be add, raise, or add temperature. So adding temperature is like adding heat, and that's on the left side, so it's going to be same, first of all. Same side as the heat is on is where we need to go to add or to raise. So since the heat's on the left, it's an endothermic, then we're shifting to the left, or not us, but LeChat is going to shift to the left. And that's all there is to that problem. So let's go down now to number 38, and let's take a look at that one. In this reaction, zirconium iodide is going to be forming zirconium and iodine, the gas. So, look, we got two solids. The only guy in the equilibrium is the iodine. Oh, and it's endothermic. So, as you can see, again, I've added the heat to the left side because it is endothermic, and in this particular case, will an increase in temperature. Okay, so let's go back and work out the logic now. An increase in temperature, that means a higher temp, or, yeah, higher temp is good. H-I-G-H-E-R, temp. Now we go over and we figure out what LeChat wants to do. Well, you know what LeChat wants to do. He wants to lower the temperature. So to go or take away, we have to go opposite. Since heat is on the left, opposite of left is right, and that becomes our shift. Not too bad. I hope you're starting to get the hang of this. Now let's go to number 39. In 39, let's go back over and take a look at the problem. In 39, what do we have? The reaction is a hydrocarbon, C2H2, and bromine is going to make brominated hydrocarbon, C2H2Br4. Wow, that's a lot of bromine on there. And look at this dude. He is exothermic. So now we can see exothermic, and that means heat is on the right-hand side, and it becomes a product. So, will an increase in temperature, oh, what is the thing going to do? All right, let's find out. We are exothermic, and we are increasing temperature. So, increase temp And LeChat wants to, you guessed it, decrease or lower. Why don't we call it lower? Lower temp. And if we want to lower, we have to go opposite. Once we know that it's going to be opposite, we have to know which side the heat is on. And since it's on the right, we are going to go right back here and go to the left, because it has to be opposite of right. And that's all there is to that problem. Now, if we go left, what is this thing asking? Well, an increase in temperature, which is what we just figured out, shift the position of the equilibrium towards the reactants or to the products. It's going to shift it towards the reactants, as we just showed, because reactants are always on the left. All right, last problem. We're almost done here, folks. Okay, I've written on here that heat is on the left because it's endothermic, and, well, an increase in temperature. Okay, let's go back and figure what an increase in temperature does. Oh, we already found that out, didn't we? Increase in temperature. Oh, not lover. And this guy up here, we should change that, and we're going to make that lower instead of lover. And that same thing is going to happen down here. We're going to lower the temperature, which will make it go to the opposite, just like it did up here. Now the only question is, what side are we on? So the heat is on the left, and opposite would be to the right. And that is our shift. My hope is that you're getting a better feel for this, that it's starting to make more sense for you. Go back and review anything that seems strange to you and go over it until it makes sense. It just takes time. Give yourself the time and the pleasure of understanding how this works, because this isn't something like memorizing vocabulary. You have to get the logic. I hope it makes more logical sense to you now, and I wish you the best in your chemistry studies. Good night.